Hey guys, this is Northern Oklahoma College Algebra Math 1513. This is going to be kind of a combined lesson, 3-2, 3-3, 3-4. I'm just going to kind of throw everything together in one lesson here, and we're going to find all the zeros of a polynomial function. Now you guys remember that zeros are just another word for roots or x-intercepts. So basically we're going to find every place that a curve hits the x-axis. That's what a zero is. Now something, a handy tool we're going to need to know is how a graph behaves as it goes to the left and as it goes to the right. What's the far left and far right behavior? And let's start with a sketch of a x squared graph. Everybody knows what an x squared graph looks like. It's a parabola. It opens upward. Okay? And what's its far left behavior? Well, as we look to the left, it's going up. And as we look to the right, it's also going up. So its far left behavior is up and its far right behavior is up. Now something interesting is that x to the fourth graph and an x to the sixth graph behave in the same way. An x to the fourth graph, now remember this is just a rough sketch, is going to go down, and up, kind of a W shape. And notice when I said down, that was one direction, and then up was 2, and down was 3, and up was 4. It had 4 directions, and that kind of matches up to the exponent you see. So down, up, that's an x to the fourth graph. And notice that the far left behavior is heading up as it goes to the left, and it's heading up as it goes to the right, up. X to the sixth behaves in the same way. Now it's going to go down and up, that's 2, down is 3, up is 4, down is 5, up is 6. Remember, this is just a rough graph. And that's an x to the sixth graph, and it goes up as it goes to the left. It goes up, and its behavior on the right side of the graph goes up as well. Okay, so what we notice is if the exponent is even, if it's an x squared or x to the fourth or x to the sixth, if it's an even exponent, 2, 4, 6, 8, its end behavior is going to be up to the left and up to the right. Now let's do a couple definitions while I got you here. That low point there, that's a minimum. You guys probably already knew that. We call it a vertex or a minimum. Now over here on the x to the sixth graph, we have 2 minimums. We actually have 3 minimums. These 2 here are called relative minimums because they're not our lowest minimum. What do we call our lowest minimum? Our lowest minimum we call an absolute minimum. So just a regular old minimum is called a relative minimum, and the very lowest minimum is called the absolute minimum. Now if the graph were flipped upside down, then we would be dealing with relative maximums and absolute maximums. It works in the same manner. So since we mentioned upside down, let's go ahead and flip these graphs upside down. And all you do is you just put a negative in front. Negative reverses the graph. Another way of saying is that it reflects the graph over the y-axis. I like to think of it as it just flips it upside down. And here's some rough sketches of what that might look like. So it just flips the graph upside down. The end behavior is now going down to the left and down to the right on all your graphs. So, what have we learned? If our exponent is even, 2, 4, 6, it's going to open up to the left and up to the right. If there's a negative in front of it, that just flips the entire graph upside down, and now it opens to down to the left and down to the right. What about our odd numbered graphs like 3, 5, 7, 9? What do those look like? Well, an x cubed graph you're probably pretty familiar with. It's going to look like this. It's going to, as it goes to the left, it's going down. As it goes to the right, it's going up. Now your x to the fifth will be similar. It's going to go up, down, up, something like that. But same behavior on the ends. It's going to go down as it goes to the left and up as it goes to the right. And same thing for the seventh. You just put more bins in there. So there's 1, 2, 3, 4, 5, 6, 7. And again, end behavior is down to the left and up to the right. If we flip the graph, if we reflect it over the x-axis, that just flips it upside down and kind of reverses everything. And there's a rough sketch of what they may look like. Now when you flip it upside down, when you put that negative in front of it, now as it goes to the left it opens up, and as it goes to the right it opens down. So up to the left down to the right on all your odd exponents that have a negative sign in front of them. All right? So here's a short way of writing that little note here. If I raise x to the second power, or the fourth, or the sixth, or whatever, as long as it's even, it's going to open up to the left and up to the right. That's how the graph is going to behave on the end. If I flip it upside down, now it's going to open down as it goes to the left and down as it goes to the right. An odd numbered graph like 3, 5, 7, x to the third, x to the fifth, x to the seventh, is going to open down as it goes to the left and up as it goes to the right. And putting a negative in front of the x just flips the graph upside down. So now it opens up as it goes to the left and down as it goes to the right. These are just handy little tricks to keep in mind as we sketch our graphs. Okay, so your general instruction will be to find the zeros of a function. Remember, we also call them roots. We also call them x-intercepts. All right, let's say I'm giving you a polynomial. We're going to call it p, the polynomial p. And I have it written all factored out. Remember, factor is something being multiplied. So this is being multiplied by this and is being multiplied by this. So I have 3 factors. And another instruction you'll see later on is it'll say something like find the zeros and write the polynomial as a product of its factors. Well, they want you to write it like this, as x minus 3 times x plus 4 times x plus 1. They want you to factor it all out. Write it as multiplication. Okay, when you see this polynomial, I want you to see those 3 x's being multiplied, and I want you to think, okay, it's x times x times x. That's an x cubed graph. We already know that it's going to open down as it goes to the left and up as it goes to the right. So we kind of know what our graph is going to look like. Now you guys remember back in junior high when you had to find the root, back in junior high we called it an x-intercept. When you had to find the x-intercept, you had to make your y equal 0. Now a little reminder about why that happens. Let's say we have our cubed graph and maybe it looks, whoa, that's not a very good graph. But let's say it crosses right there. Where are my roots? My x-intercepts are right there and there and there. Now what are the coordinates of those 3 x-intercepts? Well, you see the coordinates are -4, 0, -1, 0, and 2, 0. Notice the y coordinate is always 0, and that's why we call them zeros. We call them zeros because an x-intercept has a y coordinate of 0. So to find the x-coordinate, to find the x-intercept, just make your y 0 and solve for x. Alright, so look at your function here. It's called p of x because that's what we call it in college, p of x. But remember in junior high, it used to just be called y. And what am I going to do? I'm looking for x-intercepts. So I'm just going to make that y 0 and solve for x. How do I do that? Well, anytime you're multiplying, see we're multiplying here. Anytime you're multiplying numbers and your answer turns out to be 0, well that means that one of these guys has to be 0, at least one of them. So that means x minus 3 has to be 0, or x plus 4 has to equal 0, or x minus 1 has to equal 0. So we just solve each of those. Alright, so we solve those and we get our 3 x-intercepts of 3, -4, and 1. Those are our roots. Those are our zeros. Those are our x-intercepts. That's all the same thing. What if I wanted to write those as coordinates? Well, remember, when you're talking about a 0, your y-coordinate is 0. So I could write them as 3, 0, -4, 0, and 1, 0 if I wanted to. Okay, before I leave, I want you to look at the roots you found. Look at that root of 3 and that root of -4 and that root of 1 and compare them to the original function. Okay, your root is 3, but your function said x minus 3. Your root is -4, but your function said x plus 4. Your root is 1, but your polynomial said x minus 1. What helps me is I think the polynomial is in the form x minus the root. So x minus the root times x minus the root times x minus the root. And then just take out the word root and put in your number for your root. So I'm going to take out the root and put in 3, put in -4, and put in 1. And I get this. The x minus -4 is a little clumsy. So I'm going to change it to x plus 4. But think about that. sometimes it's easy to find the root if you just look at what's being subtracted. So 3 is a root. That would have to be -4 because you'd have to subtract -4 to get the root, or the 0. And this 0 would be 1. Here's a quick sketch of our graph. We know it's a x cubed graph, so we know it's going to go down to the left and up to the right. So it must look a little something like this. That's just a quick sketch. Okay, what if you see something like this? What's going to happen here? Notice that exponent of 2. That's going to do something strange to our graph. If we expand that x plus 1 squared, that's just x plus 1 times another x plus 1. So x plus 1 times another x plus 1 times the rest of it. Okay, look at those 4 x's being multiplied and think, well, this is an x to the 4th graph. It's going to open up to the left and up to the right, and it's going to look a little something like a W. Now let's find our zeros, or our roots, real quick, using that trick we just learned in the last lesson just now. This root is going to be -1 because it's x minus -1. This root is -1. It occurred twice. We'll talk about that in a second. This root is 3. This root is -5. Sometimes it's helpful if you think about the opposite. If you see a +1, your root's -1. If you see a -3, your root's +3. That's a little trick you can use sometimes. Notice that the 0 of -1 occurs twice. We say it's a 0 of multiplicity 2. That just means it happens twice. If you'll go back to the original here, you see that that -1 occurs twice. These other two also have an exponent of 1. We just don't write it. So that means my 0 of 3 occurs once, and my 0 of -5 occurs once. Now, how do we interpret that? Well, here's how I remember it. If you see an even exponent like 2, 4, 6, that graph is going to bounce. I'll show you that on the graph in a minute. And if it's an odd exponent, it's going to cross. So it's going to bounce at -1, but it's going to cross at 3 and -5. Cross what? It's going to cross the x-axis. It's going to go all the way across the x-axis, whereas the -1, it's just going to touch the x-axis and bounce back up. All right, so here's our zeros of -5, -1, and +3. Now remember, the -1, we said it bounced. Now we know from our end behavior that it's going to look something like this, like a W. And so I know it's going to go up as it goes to the left, and it's going to go up as it goes to the right, and there's going to be a W shape. I also know that it crosses at -5, so it comes all the way across the x-axis, and it crosses at 3. I know it comes all the way across the x-axis. But at -1, our 0 of multiplicity 2, it's going to bounce like that. And by bounce, I mean it just barely touches the x-axis and bounces the other way. Normally, we would expect an x to the 4th graph to cross in 4 spots. We would expect to have 4 real zeros for an x to the 4th graph. This one apparently only has 3, but our 4th 0 happens here because of the multiplicity 2. So that 0 actually happens twice. So we have 1, 2, 3, 4 zeros. On a normal w to the 4th graph, those 4 zeros are easy to see. This isn't so easy to see because this one occurs twice. Alright, this polynomial looks extremely difficult, but we're so smart now we can use all these little tricks to kind of get a picture of the graph. First of all, we know we have a 0 at -4 and +1. Now we got to figure out what happens there. Does it cross or does it bounce? We know it crosses at -4 because our exponent is an odd exponent. So it's going to cross at -4. It's going to go all the way across. And we know it bounces at +1, but we don't know if it bounces like this or bounces like that. So we got to get a picture of the graph. Okay, think we have a negative sign, we have x cubed, and we have x squared. Altogether, that's going to be a negative x to the 5th graph. So it's going to look something like this. So I took a little peek at it on the graphing calculator, and it looks kind of like this. It comes down through -4, it does a little business here, and then it bounces off of 1 and heads on back down.